Hello! I almost forgot. There's one more type of problem that I can think of that you might have involving y equals mx plus b. So let me teach it to you really quickly, and I'll give you 4 sample problems and see how you do. Okay? This type of problem will be if you're given one coordinate and the slope, or if you're just given 2 coordinates and no slope. In either situation, you're being asked to write the equation in y equals mx plus b form. Okay? So let's examine both of these types of problems. First, given one coordinate and a slope. We could always start with this, right? Because you know that the slope is the coefficient of x. So we can partially write this without doing a thing. Okay. Next, we do need to find the y-intercept because that's what goes right there. So we will plot this one point, -2, -4. Slope of 3 means change in y over change in x. Y meaning vertical, up or down, and x in these cases means always to the right. Okay, at this simple level, x, change in x is always going to the right because the slope of a line is defined as how it behaves as you move from left to right. Therefore, we have to have it to the right. So what this means is 3 up and 1 to the right. Okay, so we start on this dot and go 3 up, 1 to the right. That did not cross the y-axis, so we need to keep going because our goal is to get the y-intercept. Up 3, 1 to the right. There, we can stop. Grab trusty dusty ruler out of the drawer. Make the line. Here's the y-intercept, which is at 0, 2, because I start at the origin and go up 2. So, that's it. Slope, intercept, form. Second type of problem you could also get like this is if you're just given the 2 points, no slope, no y-intercept, and you need to write the equation. In this case, there's 2 ways to solve this problem. I'll show you both. We're going to graph both points, draw a line, and then hopefully that line passes through the y-axis at a grid line intersection, meaning at a point where 2 of the grid lines cross, so we get a nice whole number. In this case, we do y-intercept. So sometimes you get lucky and it happens that way. In this case, the y-intercept is at 1. Okay. Now we need the slope. Quite simply, we can make a slope triangle between any 2 points on the line. Slope triangle. Any 2 points. Doesn't matter. I picked these 2. In this case, it goes up 3. That's the change in y. The change in x is 2, right? It moves 2 to the right. So since slope is the change in y over the change in x, we just substitute that in. We get that. Now I have the slope, I have the y-intercept, and you could probably picture the equation already. There it is. That's how you do those 2 types of problems. How about I give you some practice problems, try out this new skill on your own, and then check it when I do the answer key. All right, here we go. Zoom out so you can get all 4 of them. Here's what to do. Okay? Pause the video. Write down all 4 of these problems carefully, making sure you get all the numbers. and then hit play, and I'll go through the answer key. All right? Have fun. All right, you're back. Let's do these problems. I'm going to zoom in a little bit so we can focus on each individual problem. Okay, write the equation for the line passing through 3, 2 with the slope of 1/3. Passing through 3, 2, first I'm going to put the point on the line. I'm going to use 1/3, up 1, right 3. So it's going to have not a very steep slope. Okay, now the problem here is I've got this line happening, and if I keep going, I'm not going to get a y-intercept. Okay, now there's two ways I could solve this. One is I could get lucky and my line, if continued, could pass through the y-axis at an even number. Or I could use math or common sense. So since if I'm going up and to the right, it makes a line this way. If I do the opposite of up and right, it'll keep going on the same line. In other words, if I go down and left, right? I'm doing the inverse of both. Instead of up, I'm going down. Instead of right, I'm going left. Let's see what happens. I'm going to go down 1, left 3, down 1, left 3. And as you could tell just by experimenting with this, all the dots are lining up. It's all making the same line. So that means that's a good strategy that you could use anytime. Okay? That's the way you learn. You say, what if I do this? Then you go ahead and do it, and if it works, you keep doing it. There's the y-intercept. We already have the slope. So the equation is y equals 1/3 x, and that's a +1 on the y-axis. There it is. Okay, next. -3, up 3, right? Left 3, up 3. Then a slope of -2. Slope of -2 means -2/1, which means I'm going down and right. Since that's a negative number, that means down. Down 2, right 1. Do I have the y-intercept? No. Down 2, right 1. Still don't have it. There it is. Make the line. And I'm sure you could be thinking, hey, I don't really need to draw the line on this. The question doesn't ask me to. And you're right. But it's a good habit to do all these problems as completely and thoroughly as possible, because sometimes the questions are different and you don't want to come across something you're not used to doing. There's the y-intercept. It's at 0, -3. And since I already have the slope, and this is slope-intercept form, it's just, there's the slope, there's the intercept, both negative this time. That's it. Next, write the equation for the line passing through 2 points. This time I do not have the slope. -4, +2. Right there. +2, +5. 1, 2, 3, 4, 5. Okay. Now I can connect these things to find the y-intercept, and if I get lucky, it passes through an intersection, which it does. Let's pretend I did not get lucky. Here's another way to find the change in y over the change in x. Since I have x and y coordinates here, if I just do some subtraction, I'm going to call these x2 and y2 so I can keep track of them. I'm going to subtract 1 from 2. In other words, I'm going to take y2 and I'm going to take away y1. Then I'm going to go x2 and take away x1. The reason we use these subscript numbers is to keep everything in order, keep track of what we're doing, because in this case we want to always go from 2 to 1. That's finding the difference between these 2 points on the graph. Okay? So 5 minus 2 is 3. 2 take away negative 4 is the same as going 2 plus positive 4. 3 over 6. I'm going to go down here. I'm running out of room. So there. The slope is 1/2. Then, see, we're pretending that we don't have this dot here right now. So I could take the 2 points, find the change in y over the change in x to find the slope. Then I could use the slope to go up 1 over 2, up 1 over 2, and that's how I could still find the y-intercept even if the line that I draw does not magically fall on a whole number there. Okay? But in any case, we've got the slope and the y-intercept, so we finish by writing the equation, which is slope first, then y-intercept, which is 1, 2, 3, 4. Remember, it's called slope-intercept form. That should help you always keep these things in order. Slope, intercept, slope first, intercept second. You could think of SI, Sports Illustrated, however you want to remember that. Okay, finally our last problem. The equation of the line passing through 3, 1 and 7, 4. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. All right, now this time, this is a little rough because if I connect these 2 dots, I'm actually not passing through the y-axis at all. Okay, so what I'm going to do is I'm going to take the strategy I just taught you on the other side. Change in y over the change in x. We'll go x1, y1, x2, y2. So I'm going to take y2 minus y1. Then I'm going to take x2 minus x1. Gives me 3/4. That's my slope. Okay, so you can calculate slope just like that, which we can verify, right? Up 3 over 4. But I still need it to cross the y-axis, so we're going to use the little inverse slope. I don't know if that's a real phrase, but that's what I'm going to call it. Because we just learned that if the slope is this, that's going to take me up and to the right. If I take the opposite, the inverse sign of both of these numbers, it's going to take me down and to the left, which is going to match up and make the same line. So let's do that. So instead of up 3 over 4, I'm going to go down 3, left 4, down 3, left 4, and you see what's going on? They all line up. So if you get in a weird situation and you're thinking this line doesn't cross the y-axis, I can't find the y-intercept, you could always use the inverse of the slope to go the opposite direction. And there we have a y-intercept. That's not looking too good, is it? We know it's negative because it's below here, but we also know that if I have this slope triangle of up 3 over 4, that's not going to work, is it? This is not, my y-intercept is not a whole number. It's not an integer. So what is it? Well, I'll tell you what. It's up 3/4 from this number. So, if that number is -2, I'm going to go up 3/4, and that's going to give me -1 1/4. Or, to make that into a mixed number, -5/4. Whew! That's a tricky one, but that's how you do it, okay? So sometimes a slope triangle won't get you there. Sometimes doing all these strategies, the inverse slope, even though we can cross the y-axis, sometimes it's not going to be a whole number, and you have to not be scared of that. Just realize, hey, the slope is a fraction for a certain reason. The fraction means that for each 1x, y changes by that fraction. Okay? That's how we got through this one. We went over 1 and up 3/4. Okay? So we can use slope in that way also. Whew, there's that one. How many people got that one right? Sweet! This was too long of a video, so I'm going to say see you later. See you later.